So with that being said, I want you to try part 2. All right, so I want you to pause the video here. I want you to kind of go through and try out part 2. Once you think you've gotten it, and I know it's a little bit more complicated, but because you're starting with a motion map, but I want you to try it out. Once you think you have a good idea, you want to kind of get some help, restart the video, and we'll talk about how to do part 2. All right, so hopefully you had a chance, ladies and gentlemen, to kind of work through this. I know it started with a motion map this time, so we've only just started talking about them, but the best way to practice is to literally just kind of jump in sometimes and kind of take chances, make mistakes, get messy, as Ms. Frizzle likes to say. So what I'm going to do is I'm going to start by drawing the position versus time graph. So we're basically going to go in reverse of what we just did in the first part. So a couple things that might throw us off at first. We don't always have to start at 0. We did here, but we don't necessarily have to start at the origin. In this case, our motion map does not actually start at the origin. All right, and it can be a little tricky sometimes figuring out where the motion actually starts. The best way for us to kind of look through that is to basically look for the first dot where it has arrows going away from it, but there aren't any arrows going towards it. All right. Now, the best example looking at this is that if we look at all the little dots, we can see this is actually the end because this is the dot where the last arrow goes to, but then there's nothing else. And if we kind of work our way back, we'll see that the very first dot, the starting point, is going to be right here. So at t equals 0, we're going to be at 5 meters. All right. Now, the best thing you can do whenever you graph in this class and you're graphing for my particular taste is you need to make sure that you do a couple things. One of them is you absolutely, positively, without a doubt, must graph with a ruler. All right? Because if you draw a squiggly line, that means something completely different than a nice straight line. And in fact, as you will hear me say over and over, even though we'll have a limited amount of time together because we will not be full-time, at least not yet, a squiggly line is not a line. A line is inherently straight. So just kind of keep that in the back of your mind. With that being said, let's just kind of label this real quick. So we look at this measuring tape right here, and we can see that t equals 0. We are at 5 meters. So I'm just going to label the sides. So 0, 1, 2, 3, 4, and 5 meters. So to start this graph, we're going to start right here. Then as we kind of go, t equals, so now we start moving. Remember, every dot represents a second in this case. So the next dot right here would be at 1 second. And at 1 second, we can see that we are now at 4 meters. So we'll put a dot right here. 2 seconds, we're now at 3 meters. 3 seconds, we're now at 2 meters. All right, and right there you could say we've finished kind of the first section of motion because now something else happens. All right, so right there we're at 0, 1, 2, 3 seconds. So at 3 seconds, we get to 2 meters. Let me put that there. And you'll notice there's now a set of dots that are stacked on top of each other. All right, and if you remember from what we talked about earlier, if the dots are just kind of stacked like that, that means time is going by, but we're not changing our position at all. So as we kind of go through the graph, at 4 seconds, we can clearly see that this object is not moving. And at 5 seconds, this object still has not moved. So it's stopped for a little bit. All right, I'll keep labeling the numbers under here. Now, of course, after those seconds have gone by, all of a sudden the object starts to move again. All right, and looking at it, it's still moving in the negative direction. So now we're at, let's see, 3, 4, 5 seconds. So at t equals 6 seconds, we'll see it's now at 1 meter. And t equals 7 seconds, we'll see that our object now is back at what we consider to be the origin. All right. And of course, once again, ladies and gentlemen, as we can see, we now have another section of dots where the object is not moving again. So from 7 to 8 seconds, it's still sitting at the origin. And the same thing is true from 8 to 9 seconds. So once again, we put 2 more dots. And then the object turns around. And we see that because the direction of the arrows goes the opposite way. And this object starts moving, as I'm going to say, in the positive direction or forward again. And because the arrows are much longer, it seems to be moving faster. So in this case now, we're at 9 seconds. So at 10 seconds, our object now moves to 2 meters, looking at our motion map. And then at 11 seconds, when we end all this, we're going to be at 4 meters. All right. Now, of course, to finish off this graph, once again, we don't just have these little dots here because they look fun. You need to make sure you draw the graph using a nice straight ruler. So, of course, you make this linear, 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 linear. I am not going to try this at the moment because I will 100% not be able to do it linearly, and I will have to hear about it for the rest of the year, how I did not draw straight lines when I did this demonstration. But it needs to basically look nice solid lines like that. Okay? Now, when you draw that graph, it's going to make your life much simpler when you do the next part, which is describe the motion of the object in words. Because like we said earlier, when you have a graph like this, you need to break it up into its components, all right? Or basic little sections. Now, this graph right here, and I keep referencing it, had 3 sections. This graph has what appears to be almost 5 sections, all right? So this would be section 1, 2, 3, 4, and then 5. All right. So with that being said, we're going to describe the motion of the objects in words. And I do apologize this time. Well, I'll just kind of shorthand it. I'm really going to include only a couple things. All right. So what we're going to do is I'm going to first include the direction. In order to do that, I'm just going to show a positive or negative sign. All right. So let's start with section 1. So section 1, and of course, because it's the first section, it's important to say where you start. So we'll say starting at 5 meters. So starting at 5 meters, the object moves with a constant velocity, because it's a nice diagonal line. So it moves at CV in the negative direction, because it's going, basically, it looks like the numbers are getting smaller, are getting more negative. That just means it's moving backwards here. So it moves at CV in negative direction. And I apologize, I'm going to shorthand direction as well. So section 1 right there, starting at 5 meters, moves at a constant velocity in the negative direction. Cool. Section 2, easy. We can look at it. It's a nice, it would be a horizontal line. We know from what we talked about earlier, that means it is stopped. So section 2, object is at rest. And we can even specify where it's at rest at 2 meters. Okay. Then once again, for section 3, it starts moving again. So same idea. And because now we don't even have to specify where it is at this point, we can just say it moves at constant velocity in the negative direction. Okay, because we're going to find out is that those are the most important things we're going to talk about here. It's just the idea of moving at a constant velocity and the direction that it's moving in. All right. Then section 4, once again, nice horizontal section, not doing anything here. So object is at rest. If you want to, once again, you can specify where it is. So object is at rest at origin. Okay. And then finally, in section 5, we say, once again, looking at the graph, the object is moving at a constant velocity because it makes a nice diagonal line. But this time it is moving in the positive direction, okay, because the position is getting more positive. And even we can add on it because if we look at it, you'll notice that because the line is steeper in section 5 than it was in section 1 or section 3, it's actually moving faster in section 5. All right, so we're going to finish it up by saying object moves at faster constant velocity in positive direction. All right, and then while I'm just kind of finishing writing this up, remember, once again, and we're going to keep bringing this up over and over, negative and positive do not mean the same thing that they mean in math class anymore in here. Negative and positive in physics pretty much just mean direction. All right, so when I say something's moving faster, it means that the number, how many meters it covers in a second, is greater than something else. All right, it doesn't matter about which way it's going. So object moves at a faster constant velocity in positive direction. Okay, so I know this was kind of a lot to take in for this first worksheet, and I do know that this kind of seems like there's a lot of stuff going on at once, but what we're going to find out, and we're going to find out throughout the year in this class, is that when we go through and we work through these graphs, or we work through and we start talking about forces, or we start talking about things flying through the air, our best tool is going to be breaking up something that looks more complicated into very small, simpler parts and going from there. All right, and as we can see right here, that's exactly what we did with this position versus time graph. The same thing we did here. And we're going to find out throughout kind of the entire year, this is going to be the tools that we use to break down the motion of something. All right. So with that being said, ladies and gentlemen, if you have questions, just like throughout the whole year, I know this is kind of a weird year. It's a weird setup, getting used to this idea of this hybrid learning. But if you have questions, you need to come shoot me an email, or you need to come talk to me in class. All right, because I know that some of this stuff can be kind of confusing, and I absolutely want to get this stuff done perfectly, without a doubt, us knowing what we're doing, so that when we start to build on it as we go to more crazy things later in the year, we're not still wondering, how do we draw a straight line? All right, so that being said, ladies and gentlemen, have a great rest of the day, and I will talk to you later.